Everyone, welcome to Swift Algorithm Club. This series was inspired by RayWenderlich Swift Algorithm Club. In this segment, we'll cover linear search. You can find complete explanation of linear search in the GitHub repository. So, what is linear search? Linear search is a searching algorithm to find an element in a collection of elements. In the worst case, the time complexity of linear search is size of the collection. So this means that in order to find some element in a collection of elements, in the worst case, we need to compare this element with every element in the collection. So let's consider some examples. Suppose we have an array of integers 1, 3, 7, 9, 11, 13, and want to find 7. So in order to find the index of the 7 in the array, we'll compare the 7 with 1, and then with 3, and then with 7. And then we'll return the index, which is 2, as in our answer. So what if we're not searching for 7, but we're searching for 13? In this case, we will keep iterating through the array, and we will reach 13, and we'll return its index, which is 5. But what if we're searching for 15? In this case, we will not find the 15 in the array, so we'll return minus default values such as -1, or we can return nil in the Swift. So the time complexity of linear search will be O of n, whereas n is a size of our collection, and the space complexity will be O at 1, which is constant because we're not actually using any extra space. So let's write an algorithm. Let's create a function linear search, and as an argument we'll take array. In our case it will be array of strings, and as parameter will be name, which is also string. So we'll return the optional integer. So in case if you will not find the name in our array, we'll return nil. This means that we couldn't find it. So first we need to iterate through our array. So let's create a for loop. And I will be the index of an element from 0 till the last element in our array, and we'll compare our current element with our name, and if they are same, we will return the I as a resultant index. So as a test, let's create an array of strings. In our case it will be array of names, Alice and Bob. And let's call our function linear search names, and we're searching for index of Bob, and let's print it as our answer. So actually this tutorial is written in Swift 3, and if you want you can write in Swift 4. Okay. If it's correct, it should return the 1 as a result. Actually, it should return optional 1 because we actually return an optional integer. Yeah. So in order to get rid of this optional, we can force unwrap, and which is not safe. So we can actually use the default value as -1. So in case if the index is nil, we'll return the -1. So for example, we're searching for look in array, so it should return -1. Yeah. But what if we don't want to search in array of strings, but we want to search in array of integers? So in this case, we need to change our type to integer, and let's also rename it numbers, and it will store 100, 200, and 300. And we're passing numbers, and we're searching for index of 300. So if it's correct, it should return 2 as a resultant index. Yeah, it's still running. Yeah. What if we want to search for 400? Yeah, it's -1. So actually, it's not very useful in every time in case when type is changing the modifying the function. So instead of this, we can use generic types in Swift. So better or generic types. Generic types means that the types is not specific type, but you can use any type. So in Swift, in order to create a generic function, we can use some placeholder type. So let it be t. So instead of using the integer, we can use our type, and this optional integer will stay because actually we're returning the index, which is index in any case will be an integer. So, but actually it complains execute com t is not used in function signature, but actually there's in order to compare the type generic types, we should confirm the equatable protocol. So what is equatable protocol means that types that correspond to the equatable protocol can be compared. So in this case, we're comparing. Let's put it, and instead of name, let's put it object and object. So instead of using some specific types such as integer or string, we're using generic types. So we can pass any type to the function. So if it works, it should return -1. Let's see. Yeah, it returned -1. Let's search for 200. Yeah. So let's modify our algorithm a little bit. So instead of using indexes and running through the array, let's use a pair of index and object, and use enumerated method on array, and also let's use pattern matching using keyword where. So where our object is equal to our object parameter object, please return y. In our case, return nil. So if it's correct, it should return 1. Actually, it already shows 1. Okay. I'm sorry for slow compiling. T, Tman, Tgmin, T. Gettable. Whenever you use the find result identifier I. Yeah. We're not using I, but we return an index. So yeah, it works. So I think it will work with strings too. Let's test it on 100. Yeah, it's 0. It works. So that's it. Thank you for watching and have a nice day.